afternoon, ladies and gentlemen. I'm John.
I'm David.
And we're here to talk to you today about...
ASR.
I was going to say the handheld penetration.
I know you were, that's why I got there in a hurry.
No, we're here to talk about ASR today. We're taking a look at some photos from a fantastic book. One of the best books written.
No doubt. I know why it qualifies for that.
Well,
Dr. Belkowitz wrote this book.
And I don't know who compared it to Mark Twain, Huckleberry Finn.
I think that was you.
Might have been. It's not that good. It's not that good. But there are some interesting pictures and there are some interesting concepts, especially if you're in the concrete construction industry, especially if you're a junior, even senior level engineer, and you've never asked these questions about the ABCs of alkali silica reactivity.
Yeah, I mean, John, let's give credit where credit's due. This is like a field guide. I mean, it has pictures of all different kinds of ASR. I don't know another source that is like that you just go page by page, and you can, if you see something in the field, you can find it in the field guide.
And it's alphabetized.
It's
fantastic. Okay, so we're going to look at two pictures today of the same dam in New Brunswick, Canada. Already setting the stage, aren't I? Right.
I'm guessing this dam has pretty severe ASR problems.
So, and there's a story. So it's story time! It's a different type of story, though. It's a story that you have to garner from what the material properties are trying to tell you, that it's been there in place for a long period of time, and what we're going to do for the future. Is that a fair?
Yeah, I think so.
So let's try to find the story. So the first, okay, yep, got the second one. So here's the first one. This is from inside the dam.
Yep.
Massive amount of ASR attack at the, I can't say the name of that dam, in New Brunswick, Canada. Inside the gallery of the dam, ASR gel oozing and rust.
Yep.
Staining from the cracks.
Yep. Got mini stalagmites dripping down.
So that's inside the dam, where it looks like a horror movie.
It does. It is a horror movie.
It is a horror movie. Okay. Yeah. This is the exterior of the dam.
I'm no more happy looking at the exterior of the dam.
Now, the reason...
I'm still kind of horrified.
The reason why David's looking at this is David is our dam engineer.
That's DAM.
So he knows more about dams than anybody in our company. And how long did you work at the Denver Federal Center for Bureau of Reclamation?
About 35 years.
35 years.
Pretty close.
Pretty close. And there was more than one dam that you worked on?
Yeah, the Bureau had about 110 concrete dams.
Concrete dams.
I worked on many of them.
Many of them.
Yeah.
So we can say that you are the most experienced dam person we've got.
Yeah, I think we could close out the board here. Yeah,
sure.
I think that's right.
So when you look at this and recognize that it's been in place for, I think, 30 years plus or minus 5 years, and you understand that they're going to be putting in another dam, stripping and ripping this facility out and putting another dam in its place. What is the, I hate to use the word story again, but what is the story about the raw materials, the environment, the alkali content, the moisture, the steel that you see from these pictures?
Well, I mean, there's a lot of dams in Canada. They're all under the same meteorological environment. So, I don't think we can accredit this to rain or freeze thaw. I mean, there's tons of excellent dams in Canada. So this is a material problem.
So a material problem, and it's not a material problem that we can ignore.
Oh, no.
I mean, whether we look on the outside of the dam or the inside of the dam, if we ignore this problem, whatever structure we put in place a couple of decades down the road, it's going to be a mess.
Well, it's pretty much a mess now.
Right. Right.
So let's ask ourselves two questions. A, is this bad? Yes. This is bad. B, is it going to, number one, get better? 2, stay the same? 3, get worse?
Is there an option for 46 or 546?
I mean, can we agree it's probably going to get worse?
It's probably going to get worse. Probably going to get worse.
I mean, there's anecdotal data that you can halt ASR by putting pressure on it, that it can no longer, the gel can grow and expand, and you can hold it in place and halt the action. There's actual cases where they let it swell and they do saw cuts and let it swell out into the saw cut and try to improve it that way. But, you know, on a risk basis, you know, who's willing, what company, what person, what principal engineer, what dam engineer is willing to take the risk on this? I'm not.
Well, somebody is taking the risk on it because they are replacing the dam.
Right.
And
so that's eliminating the risk of it.
Well, as I understand, they're replacing it with a similar mix design. Maybe not the same materials, because we're talking decades later, but a similar mix design. And I think, Mike Thomas, you might want to double check that. Can you double check that? Yeah. So let's for a second assume that we don't know the mix design, right? Let's not even worry about their mix design. Based off of the anecdotal evidence, field and whatever cores that they did, is it reasonable to argue that if we're going to put a new mix in, we're already using local materials, we're already taking a risk? Do we take a step in what might be the forward direction by using either different type of mix design with the same type of raw materials, or either getting new raw materials in? Does it pay to do that, not take a risk at all, get some inert materials from a train right away? Or do we start using admixtures that can possibly diminish the risk?
We should do anything that we can. I mean, we don't want to repeat ourselves and use the same mix, the same materials. You know, usually in dams, I mean, there's so much material, you use material that is close.
Right.
You know, so you just, you know, when you do the foundation, you dig that out. If there's good material in there, you use that in the mix. You don't haul in any longer than you have to.
Right.
So
that's not a realistic option.
Well,
hauling in from 2 or 3 states away.
It's expensive, but dams are expensive.
Dams are expensive. They're not tiny.
You know, they're not small, and you know, a lot of the dams in the United States, if you take them out, you can't put them back in for fish migration and all kinds of other issues.
You just have to wait till it fails?
Well, if you take it out, you just don't put it back.
Ah.
So we've seen that in the West Coast, where they've taken dams out, and for migratory fish reasons, they haven't been allowed to replace them.
Wow. Wow.
For endangered species. So yeah, you know, so let's say we get the new dam put in place, and 20 plus years from now we have to take it out again. A, it's very expensive. B, we may not put it in again, depending on the political, environmental, and other, you know, sociological concerns at that time.
And then wait a second, what about the carbon footprint of that waste?
Yeah.
When you're removing the dam, it's not just the dam, it's the foundation that goes into the footprint. I mean, there's so much more concrete than what we see.
Oh, without a doubt. I mean, there's probably could be on the order of 1/3 of the height down in the foundation.
Dude, and then how much steel? I mean, well, wait, I'm sorry. Let me correct that. In the dam itself, there's not going to be a lot of steel.
No. In the appurtenance, there will be.
Right.
The spillway.
But that's still a lot of steel.
Outlet works. Yeah, there's going to be a fair amount of steel. I mean, yeah.
They're not replacing the dam. They're doing a $2.9 billion rehabilitation project so that it can reach its 100-year service life.
Okay. Well, I'm excited to see the data set that elucidates the efficacy of their decision.
So yeah, I mean, there's been cases where you overwrap a dam.
Right.
You know, you.
Right. Well, they're doing that at Shasta, aren't they, to get the height?
Shasta, they're raising.
Well, they're overlapping the top portion.
They're overlapping. Yeah. You know, in that sense, we're seeing that here in Colorado. In the dam they're doing up north of Golden.
And we need to go visit a lot of these dams.
Yeah, they have
Is that the one that's just like the surface is crumbling?
No, that's a different one. That's the one up near Boulder you're thinking of. But yeah, there have been cases where they've just, I know how much you love this term, they've candy coated the entire dam.
I do love that term. I do. I feel like I get in trouble. So anyway, hopefully you learned something from us on that. Really excited to see the information on that New Brunswick dam. Let us know if you got any concrete questions, concrete concerns.
Don't forget to like and subscribe.
Go concrete!
Beat us up!